Alrighty, good morning.
Good morning all. So thank you for climbing out of bed after TechFest and making it in for the first session of the morning.
Yes, and we are well aware that if you'd slept in, you wouldn't have to be here till 10:40. So thank you very much for getting up early for us.
So if you don't know us, this is Kirk Jackson. So he's the security architect at Xero, the world's most useful online accounting system.
World's most useful, cool.
Wait,
and this is Andy, who's the managing director of Aura InfoSec. So today we wanted to share some experiences that we've had over the last couple of years building and testing mobile apps, and particularly give a Windows Phone flavour to that. So we're not Windows Phone development experts. We are pretty good at breaking other people's web applications from a security point of view.
Absolutely.
And I've got some experience building some through Xero and testing some, and you've had some through Aura as well.
Absolutely.
So we're going to share some of those experiences, hopefully give you some tips of things to think about.
We will, and so for those who came to our previous sessions, they were quite sort of, theoretical, quite PowerPointy. So we thought we'd take the excuse Friday morning, first thing, to kind of go a bit nuts on the demo land. So we've got 11 apps overall, and there's 4 different devices being used, including Kirk's personal iPhone and a Windows 7, all developed by Kirk. So there's 44 things that could go wrong this morning.
No, it's not. It doesn't. That's not how it works. Nothing's going to go wrong. So back in the old days, we built web apps. And we had a server sitting on the internet, and my apologies, but the Mac version of Office has Mac-looking computers in its clip art collection. So the computer sitting on the internet, server just sitting there, basically generating HTML and sending it to a pretty dumb client that renders it on the screen. Then things got a bit more sophisticated in Web 2.0 land. People made things have rounded corners, and they used drop shadows, and JavaScript everything all over the place. And now some of the processing is happening on the client. So the server is more about receiving different sorts of data, maybe JSON, XML, and sending back the data the client needs, and the client assembles the UI.
Absolutely. And this, of course, is quite similar now in mobile land, isn't it?
Yeah, that's right. So mobile apps are pretty much the same as web apps, and when we test them, we think about them in the same way.
So I guess, the fact that you're now doing the full, you've got a lot of business logic, presentation layer, you're running Silverlight, so the risk of what you're now doing in the client is starting to go up quite a lot.
So the nice thing about mobile devices is that they have access to some native features of the device and native storage. So we've kind of categorized the things we're going to talk about as to where they sit on this diagram. So we're going to talk about device security stuff, so how to store secrets securely, talk about the sandboxing and other features of the iPhone App Store and the Windows Phone Marketplace, how to protect your IP. We'll talk about what's traveling over the wire. I think that all developers should really have a really good understanding of what data they're sending back and forward from the server. And then we'll very briefly cover the web server security side of it, because that's very similar to a regular web app, and we did that last year, and we wanted to do different stuff this year. So let's do the device security stuff first. So storage. You want to talk to this?
Yeah. So storage 101. So what have we got? So the things you have to look at storing in your app. So you need to be quite careful. The first thing is you need to make sure that your storage location choice is secure against all the other apps that are going to be running around you. You need to be careful of what, of course, you are storing. Is it just going to be data? Is it going to be your authentication credentials? Is it going to be secrets, passwords, certificates? You need to bear in mind what other applications sitting next to you can read. What about if we're actually viewing or copying all the data off of the phone itself?
Yeah, so you should assume that your device has been compromised and any data you store on it is now public. And are you happy with that being the case? So Windows Phone has this concept of isolated storage, just like on Windows Desktop. And it's a pretty simple snippet of code. You can basically create files and directories underneath a tree that only your app can see. And you can also access a nice simple settings API to store settings in there, and you can do local database work. And there's this nice tool called Windows Phone Power Tool, which just wraps around the SDK and lets you browse it. So there's an example of, I think my phone, I think that's their phone actually, it's their screenshot, has 4 apps installed on it. You can just drill in and see what the files are inside it.
So what you need to be aware of is instantly is that you've got one restriction on if you are another downloaded app sitting next to another app, what can you see? So in other words, if I'm a bad guy releasing a bad app, what can I see on your phone from the other side of the world? Versus if I've got access to the phone and I'm running the SDK, what is it that I can now access if I'm on the phone itself, if it's my phone?
Yeah. So the problem is you don't want to store stuff in plain text on your phone. So Windows Phone up till pre-8 doesn't have encryption. I believe that version 8 is going to. So you should assume that if someone gets the device, they can get the data off it. Now, there's not so much of a hacking community around Windows Phone like there is with iPhone, but we've seen over the years basically attackers being able to plug in a USB cable and within 5 seconds unlock the device and get the data off it. It's getting a little bit harder, but it's as simple as getting someone to browse to a PDF on their mobile Safari. That's how the jailbreaks work. So, so you want to encrypt your data, and there's a couple of different ways you can do it.
So I guess, so you've got all of the standard algorithms, well, not all the standard algorithms, so what you need to be aware of is that the encryption algorithms that will come on the Windows mobile devices isn't as rich as what you'll get in a normal Windows environment, but it's still got a lot of the key ones that you will be requiring. But as always, one of the key things that you need to look at with any remote app is its key management and key storage. So encryption's cool, but if you've got really strong encryption, but your keys are just sitting either hard-coded into your application, sitting in a text file or some config file that's sitting there, this is where stuff breaks, is that your stuff's encrypted beautifully, but if I can just read your key straight out, it's kind of pointless.
So if you've got an application where you've got sales staff entering sensitive information on the field, you want to encrypt it to store on the device. When they're not connected to your network, how are they going to decrypt that data? Like, there has to be a key somewhere. And so the key is probably going to be on the device. Either they're going to type it in every time to decrypt, or you're going to be storing the decryption key on the device. And that kind of sucks, because you basically have an encrypted blob of stuff, and right next to it you have the thing that decrypts it. So we'll come back to that in a short sec. There's another way you can store data, which is the local database. So this is effectively a SQL Server CE. I think I read somewhere that SQLite can run on Windows Phone 8, but didn't get a chance to go to any of the sessions. Busy preparing this talk. So SQL Server CE, you can run an encrypted or an unencrypted database on your phone device. If you have an encrypted database, then the app obviously has to be able to decrypt it. And it does that by providing a password in the connection string. Other little quirks of this, the unencrypted database, you can copy off your device using that Phone Explorer tool and open it up in Visual Studio or some other thing that can browse CE files. So that's quite fun if you want to browse other apps that are on your phone and see what they're storing. I did that a lot with my iPhone. You'd be surprised what's stored. But the encrypted versions I couldn't get to work on my desktop, and Stack Overflow people couldn't either. So it seems to use a different encryption than the desktop version of CE. So I'll just show you how the database stuff looks. So this is a pretty simple demo. And in fact, it's so simple that it's the sample database app that's on windowsphone.com. So this is just a really simple to-do list app. So basically it has a screen that looks like... Wait for it.
It looks like...
It's coming.
Come on.
So it needs some performance testing for this application.
Yeah, so it has a screen that basically lets you enter a to-do item. And so I'll just run the basic version of that, which is connected into an unencrypted database, and then show you what we can do. So I'm going to run it on the phone. Andy's going to
this is
be
the
nice.
high-tech emulator.
So
what we've got here, there's a number of emulators that we're using.
I think I forgot to unlock my phone before I ran it.
This emulator is actually quite high-tech. It actually looks, kind of adds like a sort of photorealism, like hand jigger.
Where are we? So this is basically just connecting to the database with no encryption.
No, you don't want to stop debugging.
No, I don't want to stop debugging. Why does it want me to do that? Cool.
Here we go.
Okay,
Need a little window.
Need a little window.
Ooh.
Okay. So here's my app.
So it's actually running.
Wow. I can install a sample and run it.
Or what's your password?
This is not a password, this is a to-do item. So that's my to-do item there. I obviously can't spell, but I think the demo still works without being able to spell.
To-do ITR, that's fine.
Yeah, and so then we'll just stop that and I'll just show you what it looks like on the device. So if you've got your phone plugged in, developer unlocked, Zune running, and the SDK installed, then you can browse what's on the device. And this is just a nice UI that wraps that, which was that Windows Phone Power Tool. And this also lets you upload ZAP files to your device as well as browse the files. So I happen to know that my application is the one that starts with 77. Each app has its own GUID. And there's the database file, and I can copy that to my local machine just using this get. And here's one that I prepared earlier. So this actually works. The only reason I didn't want to do this in front of you is I had problems with file locking issues. So I decided that it would be safer.
A pre-canned one would be far better.
To show you just how easy it is to connect to the file that you get off your phone and go futzing around looking inside it, which is always the sort of thing that people do with secrets.
And it's interesting, if there's one thing you're going to do after this, it should certainly be grab your phones, have a look at the data on it, start snuffing all the information that goes across the wire from your phone.
So this application has two database tables. Inside the table are the to-do items. That was one that I typed earlier, so the text doesn't have a spelling mistake, but you kind of get the idea. So now when I get the encrypted version, use the encrypted version of the code, which is very easy to do because I've already written it.
Oh, nice.
Wait for it. Wasn't that fast? That was coding. You can tell I'm a developer these days. Not really. So we'll just redeploy the app. So now I've got the password 123. Probably not the best password to choose.
123.4 might have been an improvement.
Yeah, 3-digit passwords. This is not going to work. So the reason it's not going to work is there's already a database on that device and I forgot to delete it. I should follow my own script. So I'll try to delete that database and start it again. Did that stop? Oh well, looks like it's going to work anyway. See what happens. So now we get the same app. If I wanted to bring it up on the screen, I could show you I was adding an item. I added an item that was called to do. And then let's have a look at how that file now looks. Let's see. So I can't connect to this encrypted database, and when I open it in a bit editor, a binary editor of some sort, you see this Microsoft Enhanced Cryptography provider, and the unencrypted database, I was actually just able to open also in a text editor and find my string inside it, so dump the contents, whereas the encrypted one, as you'd expect, you don't find your text in it. So that's just an example of how easy it is to do encryption.
So it should be in this day and age, so no one should be using, in the same way that no one should use plain text passwords these days, no one should be using unencrypted storage on the device. That would just be a pretty silly design, wouldn't it?
Well, if it's a secret, if you're not storing anything secret, then yeah, go ahead and don't encrypt it. So the next thing that you can do on your device, so we talked about how annoying it is to manage encryption keys, and on Windows desktop this is solved using the Data Protection API, which is basically an API that lets you give the operating system something to encrypt. It encrypts it and gives it back to you, and the user applications don't know how to decrypt that, and the key's based on the user's credentials they use to log in.
Yep.
On the phone. I think it's based on the phone ID, and it's also by the app, I believe. So it's a pretty simple API. Basically, you just grab a couple of bytes, normally by converting strings into bytes, pass them to this method, and it encrypts them and gives them back to you. And then only your application on this device can decrypt it. If someone clones the device onto some other media and takes it home to try and brute force it, they're going to have trouble actually getting that data out. I haven't actually seen if anyone's broken the DP API on Mango, but it's probably the best we've got at the moment.
Absolutely. And at least, I guess, if you're using at least the DP API, then as it enhances in its security, then so does the code that you're using. So I guess it would certainly be the best recommendation at the moment. If you've got any keys, any secrets, any passwords, it will be the place to be putting them.
Yeah, so, I mean, DP API doesn't actually store them for you, so then what you do once you put them in the DP API, got them encrypted, is then you store it in local storage or you store it in the SQL database. So the kind of pattern that I'm thinking that we'd use is we'd have a connection string, we'd get the password for the database connection string by decrypting some data out of the DP API. Man, that's so annoying. I should turn off phone lock, shouldn't I? I'm a Windows Phone newbie. So just to show you a really simple example, so this to-do application, it's got some bit of string which is going to be my database password. I basically turn that into an array of bytes, pass it to the encryption algorithm, which does the encryption, gives me a blob which I can store in my settings of my app, and then later on when the app restarts I can just get it back out and decrypt it. So that's my password there, decrypted again back into the original characters. So that's covered the Windows Phone storage features. If you're developing for iPhone, there's an equivalent to the OS X keychain on the iPhone device. And it's actually, I think, kind of cool, but there's a few gotchas, so I'll just briefly cover it. So it's a place where you can store small bits of data. You basically have a key that you use to look it up, and then an encrypted value, and the value is segmented by application that runs on the phone. And the Objective-C layer is supposed to stop apps from reading each other's data, which as far as I know works. And each thing that you put in there, you give it a kind of accessibility scope. So you say, my application runs in the background, so it needs to be able to decrypt the Exchange password and connect to the Exchange server, even if the phone's locked. So you might set that to be accessible always. Or you might say the user has to be present, they have to have unlocked the phone once, in which case you'd use one of these other flags, like after first unlock, or they have to be always present and it's got to always be unlocked. So you can kind of tell the phone when it should give your application the data. And that means that if there are some issues, or if you don't want the app running in the background, you can specify the levels when it can run. So I won't go into that too much because this is not an iPhone talk. Other thing that iPhone's had since I think it was 3GS is device encryption, and I think it's gotten better in 4, which uses AES 256. So that means that if someone gets the device, copies the RAM flash, copies the flash off of it, it's still encrypted and they're going to have trouble reading it. That feature's also coming in Windows Phone 8, I believe. But I don't work for Microsoft, so...
Can that be confirmed by anyone here? Do we have BitLocker in Windows Phone 8?
Yes.
Excellent.
Awesome.
We knew that. So it's definitely coming in Windows Phone 8.
Bing told me it was so I believed it. So sandboxing's all about protecting your apps from each other.
Absolutely. So, and I guess this is where you want to be particularly careful that, again, you cannot trust any of the apps that are sitting around you. So again, coming back to our theories of when we're writing these apps, you must assume that your app is going to get attacked from side by side, that all of the other apps on the phone are trying to read your data, they're trying to steal your data, they're trying to steal your keys, they're trying to stop you working.
So this is a big problem with desktop apps, right? Because desktop apps can look around at other parts of your C drive. And something they've really tried to lock down with these closed ecosystems like the iPhone and not Android so much-ish, and the Windows Phone Marketplace, is to make these apps self-contained and really make them safe so that people can feel confident they can install apps. They're not going to snarf their contacts or whatever. And the Windows 8... whatever they call Metro UI now, that's a similar kind of thing where each app is running in Silverlight and it's sandboxed at an API level. So they do this by providing a safe set of APIs and then validating that your app only uses those APIs. And so that's part of the marketplace validation process. You've probably heard of it. They'll check to see if you're using protected APIs. With Silverlight, they have a slightly more robust way of doing that, I think, than Apple's Objective-C, which kind of just turns into binary code. And people have managed to get stuff through the App Store approval process. It'll be interesting to see if they do on the Windows Phone Marketplace. So people have managed to get stuff through the App Store process that calls forbidden APIs that are available.
But particularly they found it was through the update process. So there seemed to be, in the early days, far more stringent behaviour over checking an app the first time it was released over versus checking updates to an app. So again, a number of the malicious apps were released as quite clean on day one, but then a few updates would occur for them, and when it was those updates that would start to be introduced more malicious code. Just because it was already a trusted app and just the rechecking process was just a little easier to do.
Yeah, so that's just something to watch out for, I guess, if you're a user of a phone. So apps are isolated, which makes it hard for them to talk to each other. So you've probably seen other talks where you can get your Windows Phone apps to talk to each other via pickers and choosers and sending each other that sort of thing. It is possible to run native code on a Windows Phone device, like it is just a Windows CE or whatever operating system underneath, but only special people get to do it. So that's not us.
No, we're not special.
Capabilities. This is pretty basic. It's a nice feature on the Windows Phone, which is that apps must publish which APIs, which phone functionality they're going to access, such as the camera or appointments. So interestingly, iPhone doesn't do this. So one security review that I did, we were able to subvert the iPhone app to silently record audio and upload it to a server while the app was running. So basically we turned the app into a bug, which was a really cool finding and made the developer very upset. But that's because iPhone doesn't prompt you. You don't know what iPhone apps are doing when you install them, and there's just countless examples of apps that upload your address books to their server just for the heck of it. So Android and Windows Phone, they have a bit more of a model around apps having to ask for permission before they do stuff. Intellectual property. Now, this is an interesting one.
Because you want to make sure that, obviously, the IP that you store both in your code, the IP that you store with maybe the data you're holding, the imagery, the videos, there could be a whole bunch of stuff that you are now releasing down to the client. And so, again, just protecting your IP is another perspective of what you want to be aware of your client code that's running.
So we always say that security through obscurity is a bad idea. So you shouldn't really have any secrets in your code. You should assume that attackers can read your code, but sometimes you don't want them to, right? And with .NET code, we know that it's compiled to a nice, friendly intermediary language, and the intermediary language can be reversed into pretty much C# code again. This is also an issue on Android. There's something that turns the DEX code back into effectively Java bytecode. And Objective-C, it goes to a slightly lower level, but it's also possible to see what apps are doing on there. I think .NET's easiest way to do it.
So is there any way we could maybe see that in action?
Yes. Funny you should say that.
Wow, that's amazing.
So there's this really cool tool called Reflector.
Here's one. Good prepared earlier.
So who's seen Reflector? Yeah. So if you're an open source person and you don't want to see other people's source code, then you close your eyes, because it might accidentally show up on the screen and it might spoil you for the rest of your life.
And I think it's one of these things that, again, because of course, we don't want to get Microsoft in trouble for releasing, copyright stuff. So again, under that disclaimer, so Microsoft have got no responsibility for you keeping your eyes open now.
Yeah. Cool. And basically all I'm showing you is what gets sent to the phone. So it's not really a secret. It went over a wire, and in fact it's not even encrypted on the wire, and you own the phone, so theoretically you should be able to look at what's on it.
So it's pretty much
but
open
unfortunately
source.
That's not how the law works. Interestingly, when you use Windows App Store, Zune, or the marketplace on the phone, it downloads ZAP files to your phone, and they're just zip files. And originally they were nice zip files that you could intercept on the wire, and in fact the URLs were unfortunately published for every app, even if you hadn't paid for them. But now they're doing some kind of DRM nastiness, and you can't open the files as zip files. But luckily last year I downloaded some before they did that, so I can just show you what that's like. So here's the Twitter app from, looks like November 2010. I don't think it was 2 years ago. Whatever. So here's a Twitter app. So the DLL for, I guess, the main menu part. This computer's so slow. So basically in Reflector, it opens it, looks at all the classes, and then you can try and find the main start or whatever it's called. And you can effectively look at that person's code. And your protection against this as a developer is to obfuscate your code. So there's tools like Dotfuscator and a few other ones that make your code hard for tools like Reflector to reverse. In this case, I can read that. It's pretty much C# code, but other apps do a better job of it. Other things you should think about. So if you've got applications, audio. So if you've got applications that send content up to the user, basically you're sending them everything that your app needs to run. So I'm going to make that open. So this Star Wars game, it has videos in it and audio in it. I mean, that's not such a big deal. You can watch them on YouTube. But it is a good excuse to show a Star Wars.
It's a good excuse for a Star Wars. It's like first thing on a Friday morning. Had a coffee, had good breakfast.
Han Solo
get a bit
is
of Star
cool.
Wars.
I don't know who that guy is. That guy's boring. Okay, cool.
He's 6'6", but he's kind of cute, you know. Not that I'm into big hairy. No,
You're talking about Han Solo.
Oh, dude. Yeah, no, no, not that one either. Oh man, I'm confused.
Okay, so as you can see, it's just a zip file. When it's on the phone, it's obvious the phone can read the DLLs on it, so I assume that it's possible to get them off, even though I don't have tools that do that. So assume that once you've built your application, everything is public. So do anything security critical on the server side, I guess. Is
Which,
what
funny
we're
enough,
saying
was
there.
kind of similar to the message that we had, of course, in web development land, is that any security that you want to put on the client, any stopping people of doing bad things that you want to do on the client is purely just for your usability perspective. Every single security step must always be performed at the back end. I think we said that yesterday. We're saying it again.
We're like stuck records.
Oh, yeah.
Cool, so now I'd like to talk about stuff going over the wire. Now this is not that TV show that over 3 seasons and the really fast Chicago talking. I never really got that show. This is just the piece of cable going between your phone and the server. And it's a nice place to look at what's traveling between your applications. So even though you control both ends, you don't control the middle. And in fact, you don't even really control the client. And in fact, if you're not patching, you probably don't even control your server. But that's another story.
So most things are just random luck if it actually works.
Yes, you control nothing.
That's right.
Trust nothing.
And what's kind of weird is that, so again, we mentioned this yesterday, that like a web land, people are used now that, HTTPS is a good way to transfer data because it seems to be more secure. And yet we still find time and time again, the mobile apps don't seem to be in that space yet. There seems to be this strange understanding that your stuff's not going to get sniffed from a mobile app. It's quite different. There's a different data transfer, obviously, so we don't have to encrypt across the wire.
That's right. So the sort of things that your apps typically transfer over the wire is the authentication, so logging in and keeping some kind of cookie or token to say who you are for subsequent requests. Some apps will transfer code, so maybe you're doing some remote code loading, less likely on a Windows Mobile Silverlight app, but maybe JavaScript loaded dynamically. And then the main thing, of course, being data. So let's just look at some things that could happen.
So I guess, so the first bit we got is just the passive side. So this is us just listening to the data that comes through. So this is, I guess, obviously unauthorized interception of data. So whether it is your authentication credentials, it's your tokens that we're going to reuse in a different app, whether it's just the data itself. So there is one attack which is just listening as the stuff goes through.
Yeah, so these man-in-the-middle style attacks, or Mike in the middle, because Mike kind of looks like that guy. Anyway, these man-in-the-middle attacks, you don't even need to know that it's happening. Like, you're on a public Wi-Fi in a network like you are today. Someone else is just sniffing your traffic going past. It's totally possible. Happens all the time. So things that could happen. So this is a web example, but pretend this is an iPhone app or a Windows Phone app.
Windows Phone app.
So, there's an app that's got some purchase thing. Maybe you can save your credit cards later purchase. It's very clever. It only shows the last 4 digits, so they're nicely masked, PCI compliant. But actually what's happening when the app is connecting to the server is it's requesting the data to display in this drop-down as a JSON structure. And they're just using some database table ORM to JSON tool, like JSON.net or something, which is serializing the whole structure from the database, including the credit card number and the expiry date and everything. And I've seen this in pen tests. I haven't seen this exact example, but I've seen an example that is just as bad.
Absolutely.
Formatted differently. So this fails on many levels, like storing credit card numbers. That's bad anyway. Most of us don't need to do that, shouldn't do that. Transferring more information across the wire than is needed, and that means that someone listening in can sniff extra information.
Absolutely. And so in certain test environments, we'll just sit there across a wire just with regular expressions, just looking for instance, credit card numbers. And on certain apps, you suddenly get a very high sort of ping rate. You just see them going past and go, oh, there's another one, there's another one.
Another issue that we see often in mobile apps, or I think it's an issue, it's kind of, it depends on your terminology, definitions, is lots of apps are ad supported. And lots of them use technology like Flurry, which I think you sign up and they give you a kickback every time someone views your ads inside your app. So that's how you earn money. And how these apps work, these plugins work, is you embed an ad control in your application, and it connects back to the server and delivers ads to the user. And typically what they'll do is just do a get over HTTP to get an advertisement and pass the UDID in the URL.
So the UDID, what's that?
So that's the universal, unique,
device ID.
Unknown device identifier.
Yep.
So it's been in the press a bit this week actually, because basically the UDID uniquely identifies your device. Doesn't matter who you're logged in as, doesn't matter if you've sold it, someone else has bought it, your UDID stays the same for your phone forever, unless you jailbreak it and change it. And so what this means is that advertising networks like Flurry can start to correlate usage across all applications that are displaying their ads, because they know that someone using Pinch Media, or whatever this ad was, saw one Flurry app with the same UDID as over here. And one bad example of this was one of these apps where you can find people who share similar tastes to you. And what the big...
I'm even pulsing.
And so this application...
I do like following the 6-foot hairy thing comment. Oh, man.
Yeah, there's nothing wrong with that.
We're not recording these, are we?
So this application, people didn't want other people to know that they were using this application for some reason. I'm not sure the background of it. And they'd get their iPhone 3GS and they'd want to sell it and buy an iPhone 4. So they'd do a factory reset, ship it over and sell it to someone on eBay, ship it to them. That person would turn it on, reinstall this app, and boom, they're logged in as the first person to this application. Because this application was using the device identifier as the login. So, it's kind of inconvenient to make people type in their passwords over and over. Let's just log the device straight in. And that could be very embarrassing for someone who's a pulsating member of this application.
Yeah, baby. It's actually quite a nice... I thought this was one of my better shots, though. Yeah. This is a good one. Not as buff as that guy. No, sorry. So this week, some hacker person posted on Pastebin that they'd retrieved from an FBI laptop, which sounds like it wasn't true, but they'd retrieved 12 million UDIDs linked to personal information. So this is apparently President Obama's UDID for his iPad, with his UDID, his device name, and iPad. Who knows if that's true? Yeah, apparently.
But you can pump your own UDID into this application and it will tell you if you were one of the 1 million that have been leaked so far. And then you can just go around the internet and see what other things you can find out with someone's UDID. So we can find out that the last game President Obama played on his iPad was Sheep Launcher Plus. So obviously the Afghan war is not going too well.
Exactly. Yeah. But it's good how they make strategic decisions, I guess. Yeah. It's like, so Obama,
he has a gamer score of 250, so he's doing well.
So he's doing well, exactly.
So device identifiers are evil. This is where, I guess, it gets into a bit of personal opinion. I don't like marketers tracking me. I don't like people being able to correlate my activity between applications or websites.
But it also shows how dumb it is that if you're going to use those IDs as an authentication mechanism, then that's a little unwise, perhaps?
Yeah.
So, but I guess... I'm sure that Windows 7, though, doesn't have the same kind of device unique ID, does it?
Yeah, so pretty much any phone, of course, you can get something unique about it. Just like any web browser, you can store something unique about it. Apple's outlawed the use of UDID. Doesn't mean apps don't use it. They've only recently made that rule. Windows Phone, you can look it up in the device properties. is slightly different format. But you have to tell your users that you're going to do this. So you put that as part of your manifest in the capabilities, and they will know. Of course, users won't know what that means, but at least it's kind of opt-in. There's a link to this project where people are trying to come up with a less privacy-infringing version of the UDID. So we're one application manufacturer who wants to tell that the person is the same between their trial version of their app and their paid version and their paid version and their Christmas version, to tell if that's the same user. So that's that Open UDID project.
Or I guess if anyone's actually trying to write any sort of sniffing or hacking or tracking software, then it is also useful to know that you can just request a unique device ID that remains for the lifetime of the phone. So just for those more subversive code developers out there.
Yes, don't do that. So what I'd like to show you now is my cell phone. Hopefully nothing embarrassing comes up. I see photos of my kids. Isn't he cute?
Aww.
Yeah, that's not embarrassing.
Is that really yours?
Yeah. Oh, go away. Go away, kid. Come back. Okay, I just need to turn off AirPlay again. Sorry.
Okay, so still a very cute picture. I think you're trying to go over the factor now.
Yeah.
Phone's died.
That's awkward. Maybe if I just press keys on the keyboard, it'll make it work.
I think you do. How about if I click the clicker?
Well,
no, that didn't make any difference either.
clicker's nothing to do with the phone.
Oh, wow, this is quite cool.
How about if I
So when we're looking at things that could actually crash, so your kids basically crashed the demo. They actually say often that, you know, kids are great testers of things because they do stuff in a really weird way, but this is kind of going beyond the realm of normality. So you go home and you go, oh man, the kids, there I was. And I click the demo.
I can't even Alt-Tab out of it. Oh well. So this is Enrico. He's 11 months. This month. He's just learned how to crawl. Does anyone know the force quit? And
yeah, no, we've done escape. No, escape doesn't do anything. Oh, there's actually, oh look, there's Kirk's wife up there as well. Look,
oh yeah, that's now.
Now this is always
this is our lounge. That's where the Xbox is there.
Sorry, you know when you say about these mysteries in life. So look, so Mia, she's lovely, right? Oh.
Yeah, what's she doing with me? Yeah.
So she disappeared. I know, exactly. You look at Kirk, you look at Mia, and you're like, really?
Yeah.
He's obviously, you got a smart brain.
Don't touch me.
Okay.
Okay. No, seriously, I don't like that.
You dig me, baby?
Get your pulsating member off me. What was that application called that I was using to display this phone? Reflection, that's it.
It was. It's funny the batteries keep running out of these things.
So this time I won't mess this up. Apologies. You guys have got nothing better to do at the moment anyway, eh? You're all hungover. So I just wanted to show you the sorts of things that we do when we're testing an app by bringing an app up on the screen. Come on. Seriously.
It's because you broke it with Angry Birds earlier.
Yeah. So the screen refresh rate is not that great on this tool. So a tool that actually we use at Xero and you use at Aura, and it's probably because the same people have worked at both. This tool is called Burp. It's basically like Fiddler, a proxy tool. I like it because it lets you do a lot of other attacking while you're in there. But I'm going to show you pretty much just the proxy features. So let's pick some applications. So
running as a local proxy, so just so we're quite clear, so Kirk's phone is using the laptop as the wireless connection, running through Burp as a local proxy, before it then hunts all the data off down the off the data link here.
Yeah, so there's only 7 things that can go wrong.
Cat Piano, that's a good one as well.
Oh yeah, so let's not do Cat Piano.
Let's not do Cat Piano.
So I don't really use applications on my phone, and I'm not going to do any Xero day and show you applications that have security issues. I'm going to show you apps that do it well.
Correct.
Or not. So this is Treat Me. This is one of the Daily Deal websites. So interesting thing about Treat Me is as soon as I start it, it posted something to flurry.com/aas.do with this string in it. And that string's my UDID of my phone.
Oh, no.
So Flurry now knows that I use Treat Me. So
who uses Treat Me?
This is not a Treat Me issue. Every app does this.
Every app does this.
It's just if you're some kind of worrywart like me. So now I can see all the traffic that they're doing. So I can see they're calling an API. The API is returning a response with some latitude and longitude of some deals. I can sign in. and then I can watch my sign-in traffic go by on the proxy. So another app. Oh, Angry Birds. I was going to bring up Angry Birds. So Angry Birds just started. What went past on the internet then? Well, surprise, surprise. A call to Flurry with the same UDID, this time saying that I'm using Angry Birds. No, sorry, that's the Treat Me one still. It's because I started Angry Birds already. Angry Birds does the same thing. I've got another application, which is a really cool one. I quite like it. This is Sell Your iPhone App Day. This is called My Measures. You take a photo of... lost the screen share. There it is. You take a photo of your things in your house and you just drag and drop dimensions on them, and then when you go to the shop you can go, oh, this is the hole in my room where I'm going to put a shelf. Does this shelf fit? But as you would expect, this is also doing the same thing when it starts up. So My Measures is starting up and it's passing the UDID back to this company instead, sis.si, whoever they are. So you can see how someone can correlate this. This is all going over HTTP, so someone who's watching this traffic on a network go past now knows which 3 applications I'm running. They now know quite a lot about me. Not really. My phone just locked. So other things that if you're a privacy kind of person like myself, that you might find interesting. So there's a Chrome browser for the phone, and normally you trust Google. I mean, they don't do evil stuff, right? The interesting thing I thought with this, and it's actually the same on Windows Phone's Internet Explorer, is as I'm typing URLs into this, it's giving me auto-suggestions. So someone who's watching the traffic going by can see these auto-suggestions, complete suggestions going past on the wire. So here I've typed GOO, and they can see that in HTTP going over the network and see the response coming back. So they know which websites I'm browsing to. And even slightly nastier, if I'm going to https://mybank.com or whatever, even though when I click go in my phone, you can't see that, even though when I click go on my phone, that's going to be an encrypted connection, this autocomplete feature in the browser, go to the bottom. Geez, that's a lot of stuff.
That's a lot of
stuff website. Sorry. How do you use a computer? Teach me. So here you can see Chrome is sending back to their autocomplete service that URL that I've typed in. So if you were in the middle and you wanted to try and trick me into doing something, you know I'm about to go to my bank. Is Tobias here from TSB? Cool, I can show you his app then. So TSB Banking's got a really cool iPhone app. I haven't done a security test of it or anything, but you can sign up for accounts by taking photos of your passport. You never have to go into a branch. And what you can do is look at the traffic that goes over the wire when you do a login and see what comes back. And so in my proxy here, I'd be able to see the login request. Oh look, when I started up the TSB app, it asked Apple which city I live in. And Apple sent back some city coordinate stuff. And then if I'd actually logged in correctly, you'd see the login go over the wire. But I think that's because my password was only 1 character, it didn't do it. So that was really just an example of the types of things you can do by proxying your traffic through the phone, through Burp. One of these things is supposed to be PowerPoint. I think I quit PowerPoint. So while PowerPoint's restarting...
Oh, that was why...
I was going to quit everything, quit all the things. So the typical thing that people say is just use SSL, right?
Just use SSL.
SSL means that people can't read your traffic while it's going past.
Well, that's true. It's SSL.
This is not today's talk. Anyone want to do yesterday's talk again? That one.
That's today's one. There we go.
Oh. Let's pick a random slide.
I think it's a good one.
So
when it comes to over the wire, so use SSL.
Yeah, so people say you should use SSL, and in a second after this slide, we'll talk about why that doesn't always work. So here's an example of another iPhone app that got it wrong. It was called Face. They got bought by Facebook because marketing people are so creative. And their application let you connect to Twitter and Facebook, and it turned out that their server was sending back people's Facebook keys. So if you watched the wire traffic, you could then log into Facebook as these people. And even worse, this Face app, the URL of these keys was predictable, and you could find other people's keys by changing the URL. So that was kind of stupid. Actually, we're going to come back to SSL a little while away. Yep. Sorry. I had to think of something to talk about. Okay, so I want to quickly talk about the password anti-pattern. So there's this application called Twitter, and there's a whole ecosystem of applications built up around it where people would log into these apps, post messages to Twitter. Unfortunately, Twitter is now destroying that ecosystem. But the issue that they discovered was that these secrets were being shared among a lot of different apps. And my username and password I was entering into all these different websites, apps on my phone, and I had no way of revoking that. So I couldn't say, I don't want this app to know my password anymore. I had to change my password for Twitter, and then all my apps would stop working. So I wanted to talk about one sort of response to this, which is this OAuth protocol. Shall I keep talking?
Oh, yeah, no.
Cool, okay.
Doing well, yeah.
So OAuth it came out 4 or 5 years ago or something like that. And it's basically this idea that even if you're using a third-party app, you still log into the original source like Twitter. They generate a token, which they then give to the third-party app, and the third-party app can use that token as a proxy for you. So the Twitter or whoever can specify how long the token can last for. They can revoke it. They know which application's using it. They can add signing for repudiation to say no one else can call their APIs. So we use this at Xero for our API. Lots of other apps do. With mobile, there's kind of 3 ways that I've seen it work. And people talk about 2-legged versus 3-legged OAuth. This is about how the bouncing works. So the first way is that you're in your mobile app. It wants to authenticate you to Twitter, so it opens up a browser. You log into Twitter in the browser, and the browser displays a number, and then you go back to the app and type that number in. And that's 2-legged because basically there's only two little bounces between your app and the Twitter website. Yep. So that's the external browser. So that's really easy to do in your mobile app. Spin up a web browser task and send the person to the browser. The second way people seem to do it a lot in the iPhone world is to register a protocol handler so that they have a fake URL which will launch their application.
Is that you?
No, it's not me. They'll send the user to the browser, the person will log into the browser, and then the Twitter server will redirect the browser back to myapp:// The operating system on the phone goes, well, that's not HTTP, and it launches your app again. And then on the end of the URL is your token. And the third app is the embedded browser approach, where your application embeds a browser inside it and then looks at what's happening inside the browser. So it's kind of a little bit nasty in that your app is technically hosting the Twitter site inside it and could look at key presses and stuff, and then you can get the URL out of it. So I did a little example of that for an application called app.net. So as I was saying, Twitter ecosystem's been done over. These guys have come up with a Twitter clone, but it's not really a Twitter clone. It's more like the plumbing of a Twitter-like system where people can post messages, machines can communicate with machines. You subscribe to it, and then it happens to look like Twitter on the top. But the idea is that applications are core to this ecosystem. Anyway, for the purposes of this, it's a Twitter clone. So what you do is you go register your application. So I've prepared some earlier, but I'll create a new one. So my application is called appnetapp.net because...
Well, that's a good name.
I am Mr. Creativity. And you put your URL in it of your site and a callback URL, which I might use that one. Hopefully that works. So this is the application. The callback URL is the one that the AppNet website is going to redirect the user to after they log in with a token on the end. So that's created my application on the app.net service. They're going to give me some keys to use to connect to them. Please nobody write this down.
It's kind of being recorded.
The client ID is not a secret anyway. Oh, it's being
I
recorded.
think the video might have it on.
Oh, do you think that might write it down?
Yeah. But that's fine.
That's okay.
No one watches it.
I'll delete it soon. So my little application basically just has a hosted web browser control sitting in here. And when someone starts my app, they need to authorize with app.net. Once they do that, I'm going to watch that web browser control. When the URL changes to have the token in it, I'm going to grab the token off and then I can use it.
Ooh, that's smart.
This is all pretty actually crappy code, but let's say it's good code. So that's the client ID for my application. When this runs, it sends the user off to an auth URL, and that's for app.net. This is the format. You put your token on the URL, you say where you want them to come back, and then you say what things, so similar to the capabilities, what things the user should be allowed to do. So I'm going to run this on the emulator for good luck. Oh, it's already running. That's going to be interesting, isn't it? Pretty please. So there's the web browser control. Inside the web browser control is the app.net website. Yes. Unfortunately, they only have an iPhone version of their website. It doesn't look nice on Windows Phone. You enter your username and password in that embedded website. People are thinking, man, he's stupid entering his password to a public web service on the screen. Into a web browser control. And I spent the longest time trying to figure out how to modify the inside of the web browser control on Windows Phone. Couldn't figure out how to. So my proxy is rewriting the passwords and usernames to my real ones. So this is still the app.net app. It's saying this is what my application will be able to do. Actually, I must have set the capabilities wrong. And then my browser object has done a navigation event. It's come back. I get the URI that it's been redirected to. I go, that's this Call Me Maybe one. Hey, you're going to have that song in your head now. Call me maybe. Dun, 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 dun. Okay, cool. My job here is done. And then I can grab the token out of the URL. So let's just grab that token. In the spirit of all TechEd demos, that's all my demo actually does. So I never got around to doing the rest of it. So I'll show you the rest just inside a proxy tool. So now that my application's got that token, it can connect to the app.net API. And so the typical OAuth way of doing it is you add the token as a header in your request. And then they can layer on, like a 0-1, you have to sign your requests with public-private key pairs, stuff like that. But their one's pretty basic. And then you just fire the request off at their server, and then they give you an error message. So that's pretty much how it works. So the one I had before will actually work. Undo, 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 undo. Let's try that. Yeah, so here's the token I had before. I must have copied that other one wrong. So you see that it's pretty simple. My application can just basically add an extra header, and now it can see private APIs and get the JavaScript or whatever that API returns. So that's the OAuth pattern.
So the OAuth pattern, so again, just to be quite clear, your app creates a unique token. You authenticate that token at the app.net. Now every time you use that token, it knows it's you. Easy.
Yeah, so I'm not saying that OAuth is the best pattern. In fact, lots of people think that the OAuth pattern is a bit crap and not usable. But it's just a common one that lots of people use.
You don't want my drinks. No. So again, if you come back to that pattern though, so the OAuth, I guess, creating a token, authenticating a token and getting it back is a very, very common way of doing, I guess, that remote auth these days. So,
yeah. And the important thing there is you don't want people to enter your passwords for your systems into third-party products. Okay, we're going to briefly look at some active attacks.
So we talked about before, so if we're listening to the wire and we're not over an HTTPS, so one of the key things we need to be careful of now is actually injecting bad things. So as an example, what we may do is that if you get session data coming back and forth over the wire, then that could be one of the things that we actually snuff into and steal. So for example, session IDs very commonly passed back and forth. Now this is obviously somebody's done a bit of a homegrown session management. So those session tokens are stunningly predictable. So we could do two things. One is we could, if you're using your own home-rolled session management, then we could start to steal or predict what the next sort of level of session ID or token could be.
And you could actively insert your own session, insert cookies into a user's session and then get them to log in and session hijack them.
Correct. And I guess one of the issues that we often talk about is more of that session fixation, or this is where, for a token, so again, there's one, when we're talking about, I guess, inserting or modifying the request instead of me stealing your data, that if I steal your session token and try to replay it, well, that's fair enough, that's me trying to jump into your session. The other way around is that I go and create what's going to be an auth token for me to use an application. But what I do is I now inject that into your stream so that you now go and authenticate it for me. So it's a minor difference there. One is I've stolen your data so that I can be you. The other one is that I will inject my credentials or my tokens into your stream so that you will authenticate them for me. So two different, slightly different approaches. Make sense?
We should hurry up. We've only got 45 minutes left.
Yeah, we do.
Cool. So remember cross-site scripting. So the issue there in a web browser is that code and data is mixed together. And this is something you need to think about with your mobile apps as well. There's a PhoneGap session that Kevin's doing this afternoon. We use PhoneGap at Xero. Perfectly fine technology that wraps HTML5 apps to make them look like native phone apps with a whole heap of work on your behalf. But the problem is that your phone is now running JavaScript. And Mike from Aura and I did a presentation at KiwiCon where we showed how the JavaScript could access native features of the device. And so anytime you're letting code go over the wire, you have to think about what might happen. So things you have to watch out for: remotely loading Java jar files, remotely loading DLLs, remotely loading JavaScript. Anything where code is going over the wire, watch out for. Now, I don't think this is a huge issue with Windows Phone apps, but just something to think about. So as I was saying before, in that awkward pause, you normally just add SSL. And the problem with SSL, even though it encrypts, this guy can't cross the line and see what's inside your communication. The problem is that it's not infallible. So how SSL works, this is a really basic description of SSL for the encryption experts in the audience. Your client device says, I want to connect to a server, foo.com. The server uses a certain certificate. The client device says, does that certificate match the one that I should get for foo.com? And does the certificate authority exist in the authorities that I trust? So there's 600-ish certificate authorities, including VeriSign, Thought, the government of China. Probably on your corporate machines, the sysadmins have installed certificate authorities so they can watch your traffic go through their proxy logs, that sort of thing. So if the certificate authority is trusted, then you've got a problem. What the attacker would do is they'll talk to the server with the real certificate and decrypt the content locally, look at it, do whatever they want, and then re-encrypt it with their own certificate and send that on to the device. So the device thinks it's talking to the real server, but actually the attacker's in the middle of it, re-encrypting the traffic. And so the thing there is that check if the certificate authority is trusted, that step is the one that's supposed to save us. Unfortunately, this year hasn't been a good year.
No, so there's been a lot of CAs have had some of their root certs nicked and stolen, so we actually had people out there in the wild creating completely rogue certs but then signing them themselves.
Yeah, did you note, I think,
yep.
that someone broke into that certificate authority, made certificates for google.com and a bunch of other sites, and people in Iran noticed that there was new certificates in their browsers, and that was why. It was real nasty. So to combat this, so actually this is what we're doing with Burp. So with Burp, I was able to look at the SSL traffic between my phone and TreatMe or TSB or whatever, and that's doing a man-in-the-middle SSL encrypt, re-encrypt, decrypt, re-encrypt, but I've installed a certificate authority on the phone to let my phone trust that new certificate that's being generated. What your application should probably try and do is fail if the server it's talking to doesn't have your certificate on it. And this is something that I've heard a bit about in the last year called cert pinning. So the idea that you control both ends of this communication. You know that you have this certificate on this end and you have the code on that end. Why not check that it's the right one? Now, us developers, we kind of do the opposite. In development, we go disable all security checks on certificates because it's a real pain. And I think Andy was saying sometime recently that he's seen that in applications where people have disabled certificate checking and then shipped to production.
Yep, absolutely so. And in essence, you could load any cert on. It wasn't checking certificate revocation. In fact, it wasn't just checking the cert, but it was all SSL.
Yeah, so that's not good. So certificate pinning, unfortunately I couldn't for the life of me figure out how to do it on Windows Phone 7. The browser controls too locked down, the web client's locked down. There's an example of how to do it on Cocoa Touch iOS apps. So I imagine that it's possibly possible on Windows Phone, and it's something that you should consider for that man-in-the-middle scenario.
So, from the stuff that we've gone through, so what is it that you need to take away and from this sesh? Go. So, in essence,
some stuff. We skipped 2 slides.
No, we didn't.
Did you do that on purpose?
Yeah, I know. Well, look, we've done an hour. Everyone want to go for like morning tea. I want to go for morning tea. Do you want to go for morning tea?
I spent ages drawing that slide.
Oh, really? Oh, hang on. Look. There's a slide that Kirk drew.
No, actually the only thing I wanted to say, we said we weren't going to spend much time about talking about the server side of things because that's pretty standard, so that's why we left it till last. That's fine to skip that over. Okay.
So look, so the takeaway. So coming back to some of the stuff that we talked about yesterday if you came to like the threat modeling or design sesh. So the first one is that what you absolutely need to do is consider when you're designing what security you're going to put inside your app, that no, your application will be sitting alongside bad other apps that will be trying to snuff your data, get off the SCF files to read your database contents, try and get hold of your secrets. You must assume that the phone itself has been physically compromised, that it's been jailbroken, rootkitted, that now physical access or, the bad guys are doing bad things. So again, if I want to compromise your app, if I can get hold of the source code, if you've embedded a hard-coded string inside your app that is your secret that you're going to use, well, that's fine. Assume someone's got it and that they posted on the internet up on Pastebin. Assume the user is malicious and that they're going to try and do these things. Assume your communications path is being sniffed and that somebody were trying to tamper with it. Requests that your server is receiving, assume they are malicious. So assume at the back end that you now have a compromised app. So assume, do not just assume that your client's good, you wrote it nicely and it's all nice and secure. Assume that you now have bad requests coming from all of your applications. And this is again one of the bits, we mentioned it yesterday, we mentioned it twice now, it's the third time. Plan how you will respond in the event of a breach. So again, imagine now the app has been breached, you hard-coded some passwords into your code, they're now in the wild, they're on Pastebin.
How do you force people to reinstall your app? You can't, right? You have to support their app forever.
Absolutely.
I mean, have you even thought about your app failing gracefully once you deprecate your API on the server end? Have you versioned your URL for your server comms? Yep. Probably not. We didn't the first time we released Zero Touch, dolt. So that's an issue you have to think about, and that's where OAuth helps as well. If a user phones up and says, my device has been stolen, you can revoke their token for their device and the world is still a safe place. But if you're using a hard-coded password in your app to open the SQL database and every user is using the same password, someone's device gets stolen, probably you should reissue your app to all those devices because you can no longer guarantee. Cool. It's been a really great TechEd. Thank you very much for coming along to our talks. We're going to post our slides to hack-ed, so that's hacking without the education, I guess, hack-ed.com, and also they'll be on the TechEd site. We'd really love to hear your feedback. To the person that says that I'm not as funny as Jesper Johansson, I know you don't need to tell me every year. Okay. Aww. Thank you. And please evaluate our sessions and you could go in the draw to win all of these things.
Excellent. Look, any questions, just come and ask us at the front. Thank you very much this morning. Cheers.